Okay, I'll start again. I won't mess it up this time. 4 minus x squared minus 2 minus x squared, comma, x is the variable. The answer I have in the back could be honest. To be honest, could be starting at 0. I can't remember how I was thinking about it. And what were the boundaries? Negative 1 and 2. Now don't forget that's not including pi. I haven't multiplied it by pi yet, right? 108 over 5 and then times pi, if you want it. So 67.85. That's what that computer applet gave us as well, right? This thing online, I mean, go to this. Maybe I'll put a link on my website to this. And actually, I should move this. It's slightly out of the viewing window here, but to show this web address up here, right? This thing. Is there a person who, should we give credit to somebody here? Oh my goodness, look at all this. This work by Thomas S. Downey is licensed under blah, blah, blah. You know, I know this is high school and it's the just copy something out of a book and pass it off as your own, but I want to be clear that I did not make this applet. And it's a very cool applet, right? It's a very cool applet. Can't do that. No. I think if you can get just from the basic volume formula that it's as long as you know the area of the cross section, whatever it happens to be, right? If you somehow knew the area of a cross section, the only other thing we're going to do is if the cross sections were squares or something, that's the last section, right? And the last few problems in here are rotating around a different axis. Okay, can you watch this please right now? If we were rotating around a different axis, it's just going to change the length of the two radii, right? You notice how the little dotted lines are showing different place here? This is saying if you were rotating it around a different line, around this line, y equals negative 1.44, right? We've done it rotating around the axis. You have a couple different strategies you could do if you had this. If you had it around a different axis, whoa, not sure what I did there, but oh, I must have hit zoom, yeah. If you have it around a different axis, what you could do is shift the entire thing so that the axis becomes the x-axis and change the functions accordingly. All right? Is that clear? Or you can just adjust for them in the two radii. Is that going to really? That's not going to make it that much more difficult to deal with the radii involved here. If this was around the x-axis, this outside radii would just be to here, right? It'd be the height of the function. If you're rotating around this axis, the outside radius is now whatever the height of the function is plus that, right? Or minus the negative value, right? And then the inside radius is just this plus this. Or in other words, this minus that negative value added on. All right? We're going to try some of those questions because I think that's easier said than done. What did I guess for the sake of completeness I should write this here? What was this? 108 pi over 5 or 67.8 or something? I guess if we're thinking in terms of AP exam, do 3 decimal places unless otherwise told. 67.858. At least that many. Okay, rotating lines about other axes here. Or lines other than the axes. I want you to do this one by trying it first instead of me doing it for you. It's rotated about the line y equals 1. Draw a picture of it. Please notice that I gave you a very simple function here. The second function, the g of x is y equals 1. This is f, this is g. Don't forget, you got to think carefully about, I would draw a picture and draw one of the cross sections. 2 minus x squared, whatever it looks like here. I said I was going to let you do it before I tried it, but I'll pause this. That's a football. Why do I have such a big number here? I guess I don't need this. Oh, this is... Where's the little thing? Okay. Notice that actually this one I could have given you exactly the same thing if I had shifted the entire thing down one and said it's around the x-axis and that the function was 1 minus x squared, not 2 minus x squared. If I shifted each of these functions down by 1, minus 1 on both of them, then I could just make this axis the x-axis. Okay? That's one way to do it. The other way is to just consider that, whether you look at it as subtracting 1 from each of the radii as you do it, or shifting the whole thing down to begin with, it's going to come up with the same answer either way here. So here's the picture. The area of a cross section. If I really think it helps to kind of draw this and realize since you're going around this thing here, this is 2 minus x squared. Take away 1, right? You have 2 minus x squared, which is this whole thing, minus this piece here, right? 2 minus x squared, take away 1. Or 1 minus x squared. Okay? Does that make sense? That's the outer radius of this thing. And that's the radius of the disk, right? The radius of the disk is 1 minus x squared. This is the radius. You don't need another radius. There's no holes in the middle of the thing, right? It's not, it's not this kind of a shape with a hole in the middle, right? It's just this. Now, whether you realize and say, well, the axis we're rotating around is y equals 1, why don't I just shift the whole thing down? Because you could do that, right? You could just say, it's simpler to think about if I just take those two things and shift the whole thing down. If you translate both of the functions down, right, like this, and just move it down to there, that becomes 1 minus x squared and 0, right? There's no center of the thing. That's kind of one way to think about it, or just look at what the other way is just to think about what the length of this is. Leave it where it is and just say it's this height minus this height, right? Like it's the difference in those two things, right? It's however high this is minus however high the axis is, right? So it's 2 minus x squared minus 1, or 1 minus x squared. This is the radius. So the area then is that, right? Pi times r squared. Pi times 1 minus x squared squared. In other words, this is 2 minus x squared, take away 1 squared. That's where we got that from. This is from -1 to +1. Two minus x squared minus 1, or 1 minus x squared. Squared times pi. How could you use the integral? If you had to do this analytically, how could you use sort of things you know about integrals to make this simpler?
Dummy variable.
Not dummy variable. No, not dummy variable. Well, the symmetry of it, instead of doing this entire area here, you could just do half of it, right? You could just do half of it and say, I'm just going to do this and then times it by 2, right? That should be the same volume as if you do 2 pi times the integral from 0 to 1, right? Of 1 minus x squared. This should be the same thing here. That should give you the same thing. You don't have to change that if you don't want. You can, if you're using a calculator, it doesn't matter, right? It's just as simple to do that. It's no different. But you should maybe think about that's the same. Can you work through some of the rest of the questions there in the next 10 minutes that you have? Convince yourself that you understand this. Part B, draw the picture.
like, is there a big gap in the middle of it?
It's going to be washers, right?